Hey everybody, I'm Tyler Jones, and I'll be analyzing receiving efficiency in the 2023 NFL season. The goal for my project is to understand receiving efficiency among different player positions, which include wide receivers, tight ends, and running backs during the NFL 2023 season. In the NFL, understanding which players contribute most effectively to a team's success is crucial for strategizing gameplay and predicting outcomes. By focusing on receiving efficiency, this project aims to uncover the key differences in how teams utilize their receiving corps, which can help highlight standout players and effective team strategies. Here are some of the key questions I have for analysis. The first one is, how do wide receivers, tight ends, and running backs compare in terms of success rate and yards per reception? The second one is, which teams have the most productive receiving corps based on total receptions and yards by their players? My third question is, are tight ends or wide receivers more efficient in converting targets to touchdowns? Finally, which players demonstrate the highest consistency in receiving yards per game over the course of the season? Now, looking at my data set, the data I used comes from Pro Football Reference, specifically the 2023 receiving statistics page. Each record represents the individual receiving performance of NFL players for the 2023 season, focusing primarily on receivers, tight ends, and running backs. There's over 200 players that I selected for my data set, and the key metrics are total receptions, receiving yards, touchdowns, and success rate. Now here's my Tableau Prep Builder. I'm going to go into my cleaning steps now for Tableau Prep. First, the dataset was filtered to focus on wide receivers, tight ends, and running backs, which I removed all the one-off, like quarterbacks getting a reception. I removed everything that we didn't need. So just those three key positions. Next, the player names, I split them into first and last names to improve usability and clarity when visualizing and analyzing individual players. Finally, columns were renamed to provide more meaningful labels, making it easier to understand and work with the data. For example, abbreviations like REC were expanded to receptions, and YDS were renamed to yards. These steps ensured a cleaner, more focused data set that aligns with the goals of my analysis. This slide presents the data dictionary for the variables included in my analysis. Each variable is described to provide a clear understanding of its purpose, type, and measurement. POS represents player position, such as receiver, tight end, or running back, and is categorized as a non-numerical variable. Variables like targets, receptions, and yards are continuous and measured in counts or yards. For example, targets range from 1 to 181, while receptions range from 1 to 135. Metrics such as yards per reception and yards per game help measure performance efficiency and are continuous with specific ranges shown here. The success rate variable quantifies the percentage of successful receptions, providing insight into player efficiency and is measured as a percentage. Lastly, touchdowns is a discrete variable indicating total touchdowns, which is scored ranging from 0 to 12. First, I'm going to look at a parameter I created, which was the yards threshold. The purpose was to allow the user to adjust the minimum receiving yards required to classify a player as above threshold. The integer values between 0 and 2,000 and are adjustable via a slider, as you can see right here. The yards threshold parameter works dynamically with a calculated field to classify players into two categories, above threshold and below threshold. And looking at my visual I created, I set my threshold at 701 yards. So using that threshold, it will populate everybody that had over 700 receiving yards over the 2023 season. Now I'm going to look at my calculated field. This is the formula I created. The purpose, it classifies players based on their total receiving yards and relative to the yards threshold parameter. This slide addresses the question, how do wide receivers, tight ends, and running backs compare in terms of efficiency metrics such as success rate and yards per reception? This bar chart visualizes two key metrics, yards per reception and success rate. The yards per reception is shown in orange and the success rate is displayed in blue. The data revealed that wide receivers lead with the highest yards per reception, averaging approximately 12 yards per catch, emphasizing their role as deep threats and primary targets for explosive plays. Tight ends follow with an average yards per reception near 10, reflecting their role as intermediate options who balance yardage with reliability. Running backs come in last, and they average just over 8 yards per reception, which aligns with their focus on shorter, high-percentage passing plays like screens or checkdowns. In terms of success rate, tight ends slightly outperform receivers, showcasing their reliability, particularly in critical downs or red zone situations. While running backs trail both wide receivers and tight ends in this metric, the visualization provides a clear understanding of how these positions contribute differently to offensive strategies, highlighting the unique strengths of each role. This visualization addresses the question, which teams have the most productive receiving corps based on total yards? This bubble chart represents each NFL team, with the size and color of the bubbles indicating their total receiving yards during the season. Larger and darker bubbles represent higher total yardage. From the visualization, we can see differences in team productivity. Teams like the Dallas Cowboys, Minnesota Vikings, and the Miami Dolphins have the largest bubbles and the darkest color. This reflects their dominance in total receiving yards. These teams will likely feature strong passing offenses with highly productive receivers. Conversely, teams with smaller or lighter colored bubbles, such as the New York Jets and the Carolina Panthers, they have a lower amount of total receiving yards, indicating areas for improvement in their passing game. This visualization allows us to quickly identify the most and least productive teams in terms of receiving yardage and provides a high level of overview of offensive efficiency across the league. This visualization explores the question, which players demonstrate the highest consistency in receiving yards per game over the course of a season. The scatter plot represents each player, plotting their average receiving yards per game. Players are arranged along the x-axis by name, and their performance is shown on the y-axis, with markers color-coded for the darker colors means they're more consistent, versus the lighter colors they're not as consistent. From this chart, we can identify standout performers who consistently achieve high receiving yards per game, as well as players with lower averages. Players with data points positioned at the top of the chart, such as Tyreek Hill or Justin Jefferson, they clearly lead in consistency and performance. In contrast, players clustered towards the bottom half indicate a less impactful or sporadic contribution, as you can see all right here. This visualization provides insights. Now I want to go over my Tableau desktop dashboard. First, we're going to look at the player yards based on threshold. Just kind of wanted to demonstrate how this yards threshold thing worked. So if you wanted to see, alright, so this is the entire data set if the threshold is set at 1 yard. But if you say you want to see the elite players, the best of the best, you'd probably filter around 1,000, and this would only leave this amount of players, which is pretty cool. Now going back to my dashboard. For the team total yards, down my bottom left, I can filter by receptions. For now, as I said, you can see the bigger and darker colored bubbles are the highest receiving teams. But if you take away that, these are the underperforming teams, which is pretty cool. Give them a little more receptions. some more lower performing teams. And as I go up, I can keep seeing more teams come in. And if I hover around each one, I can see exactly how many yards they've had during the entire season. Or if I want to go, let's just see what the best teams are. Green Bay, Minnesota, Jacksonville. Pretty cool. And with all these, if you hover over each one, I have it where you can see the amount of yards or receptions or whatever statistic that we're measuring, so you can really dive deeper into the data. And then for this one, you can also each plot, you can see what player it is and what their average yards per game is. I'll go to my sheet for this one. So it's pretty cool. So pick just somebody random. KJ Osborne, 33 yards per game. It's an easy way to show consistency. So now for my conclusion. Our analysis highlights key trends in receiving efficiency. Wide receivers stand out in yards per reception, while tight ends excel in success rates. On the team level, some consistently outperform others in total receiving yards, showcasing the impact of their receiving corps. At the player level, our scatter plot revealed the variability and consistency, with few players showing exceptional performance. Lastly, the interactive features like the yards threshold parameter allows us to customize the analysis and dive deeper into specific insights. Thank you so much for listening. If you have any questions, please feel free to reach out, and I'd love to dive